Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry the Mystery of Molecules. Today's topic of discussion is one MCQ which is in front of you. I request you please pause the video and write your answer in the comment box, and definitely after some time we'll get the right answer with explanation. But remember, self-evaluation is essential for improvement. So that's why you should try this before I explain. I believe you have tried, so it's my turn. Now let's understand what the problem actually is. This is an aromatic moiety react with acetic anhydride with 2.2 equivalent of AlCl3. And what is the product? So this is, student, actually it is a FC alkylation, Fieldcraft, sorry, not alkylation, it's Fieldcraft acylation. Okay, so source of electrophile is acetic anhydride, catalyst is AlCl3, and this is the aromatic system. So now let's learn how the reaction happens stepwise. So first step is the electrophile generation. Acetic anhydride act as a this aluminum chloride act as a Lewis acid, and this acetic anhydride act as Lewis base. Why this oxygen, not this? Because of one canonical form. Means you may consider that the lone pair can come here and it can open. So there are other canonical forms, other one also, but I am not discussing. So this is O minus, this is. So from this thing you can understand that this in between oxygen is relatively electron deficient, whereas these two carbonyl oxygens are pretty much electron rich, because similar another canonical form is also possible for this acetic anhydride. So that's why this Lewis base adduct formation is expected to start from this carbonyl oxygen. So first this carbonyl oxygen will give electron pair to AlCl3, which is Lewis acid, and this is because the outermost valence shell of aluminium has 6 electron. So it want to fill octet, so it need 2 electron, that's why it takes electron. And after that it produces an adduct, means this, and in this case oxygen will have a formal positive charge because it have donated electron to AlCl3. Fine. So after this donation, see, these can leave. Why? Means it can leave here. Why? Because the carbon ion is stabilized. Means this anion means acetate anion is stabilized because it had formed an adduct with AlCl3, and in this way this part forms the electrophile, means this is, and this electrophile is called the acylation cation, and I guess you people have learned this thing previously. If I ask you what is the hybridization of this carbon, this is sp2. But if I ask you, you can say from this is sp2, but it has another canonical form which have hybridization sp. How? The lone pair of oxygen could be donated to this carbon, and ultimately it will produce C triple bond O, and this oxygen will have the formal positive charge. But whatever is, now positive charge is expected to reside on this carbon because carbon is relatively less electronegative compared to oxygen. So this acylation cation is the electrophile for the next step. So what happens? This aromatic moiety reacts with this. Now you can say that, sir, there are two phenyl group. Fine, it's true, two phenyl group, but there is one connection. Connection is this, means these two phenyl are conjugated together, means you can consider this thing as a biphenyl system. So reaction will happen from that side, means three type of sites are possible. This site 1, site 2, and this para position or site 3. Now question, reaction will happen where the carbocation stability is maximum. This carbocation stability is maximum when the attack happens from position 3, means these double bond attacks this carbon. Fine, adduct formation. Now after that positive charge will come. Now this positive charge have some special stability, means you can say that it can have another canonical form. What does canonical form? This can come here. So now if I draw it little different way, and by the way student, I request you please try to follow my drawing. So positive charge will come here, this, and here the double bond, and here the hydrogen, and this is the acetyl. Now because of this position, this positive charge is also stabilized by the side benzene ring. But if the attack happens from this position 2, then that kind of stabilization not possible. Not only that, you may say that, sir, for 1 possible, but that's not good because we know para is relatively more stabilized. Okay, So this is, and another thing also, there is hydrogen. So that's another biphenyl interaction. So I'm not going this thing in detail. So para attack is always favored over corresponding ortho. Now in the next step, what is expected, that this proton will be abstracted and it will come here and it will produce this acyl substituted product, and this is stable because of the aromaticity. Now, so this is nothing but a aromatic electrophilic substitution on biphenyl system. For further learning, you may visit a dedicated lecture I have already uploaded. So what is the answer? Answer is, it is the para-type substitution, or option B is the answer. So why not? As I explained, it is a meta, so substitution using another ring not possible, and this is not possible because there is one hydrogen, so some interaction possible option. And third option is, this position is not possible, there is no pi bond, okay, and this is the answer. Now before going to end, one important information, remember student, this nucleus is called Fulvene, and this nucleus has some many unique properties. What do I mean? You can see this Fulvene or Fulvene carbonyl, Fulvene carbanion, Fulvene carbocation, all those things are possible. And in this case, cyclopropane derivative, aromaticity of cyclopropene, means better to say cyclopropadiene, this thing, this also plays an important role. I have already discussed in many lectures on this. You may visit for better understanding. This is also an important concept of this Fulvene, related to Fulvene system. So in conclusion, what we have learned today, field cap reaction on biphenyl system happens and selectivity in para direction. Intermediate is a carbocation and its stability is the main factor for the selectivity, means whether orthotype, metatype or paratype product. And final case, after aromatic electrophilic substitution, the aromaticity is driving force to remove the proton, because after proton elimination the aromaticity is obtained. So this is the end of the discussion. Thanks for watching, and if you think my contents are worthy, then please help my channel to grow, and most importantly, if possible, please visit another channel, Climate and Chemistry, where I upload global warming and climate change related videos. So take care, see you in my next video. Bye.